Hi guys, in this video I will be talking about basic operations on signals. For example, we talked about like we have a signal like that, or a signal like this, or any signal like that, right? All of these are signals, and the independent variable was like time. In most of our cases, the independent variable is time. So if you would like to perform some operations on these signals, for example, I would like to increase the amplitude. I would like to add two signals like x1 of t plus x2 of t, or if I would like to multiply two signals or with some scaling, it is possible. I would like to take the derivative of a signal. So all of these are possible if I would like to perform on dependent variables. If I would like to perform operations on independent variables, then I may perform some operations on the t variable, okay, the time. So I can change the time scaling. That means I can make the signal faster or slower. I mean, by time scaling, I can run the same signal. For example, the signal is like that. I will have the same signal, but in a faster time. Okay, nothing changes in the signal. Only the time is faster, or I can have it in a longer period of time, so this will be slower. If I would like to talk about reflection, like for example, here is my signal, and if I would like to perform a reflection on time, then I would have this with respect to the y-axis. Okay, reflection is about the taking the symmetric of the signal with respect to the y-axis. I can also perform time shifting. For example, I would have this kind of a signal, and I can perform shifting to the signal or shifting to the signal. This is called delaying, okay, geciktirme. This is called advancing, okay, öne alma. So I may perform different operations on dependent variables or independent variables. Dependent variables are usually current, voltage, pressure, those kind of things. Independent variables in this subcomponent, it's the time variable that we will be talking about. Let us work on several examples, and I hope you will understand it better. Okay, now this is my x of t. This is my signal, and I would like to find out x of 2t. Okay, when you see 2t, it means my signal will be faster. Okay, I will have my signal happening in a shorter time period. Same sound, but with faster kind of mode. Let me tell you, for example, if I say merhaba, this is a signal, right? If I say merhaba, the same information is there, but I am saying it in a faster manner. If I'm saying merhaba, it is a slower version of the same information. So we will talk about faster and slower versions of the same signal by just multiplying t variable with a certain a scalar. If a is greater than 1, then it will mean something else, which is going to be having the signal faster. And if a is less than 1 and greater than 0, then it will be slower. Okay. Later on, we will talk about some minus t, minus 2t kind of things, but let us focus on time scaling for the time being. Okay. What do you see here? What happened when I make the signal faster? That means my signal was like merhaba. Now it's like merhaba. It is faster. You see, the time has changed, like it become faster twice, two times, okay? So now this is not -1, but it is half. It's not going up to 1 second, but it is ending at 0.5 seconds. So This is something critical, and I want you to understand. If you think in the other terms, same thing this time. We are not, we are having the same signal starting here at -2 and ending at 2, and my signal will have the same information, but now in a shorter, in a longer time period. Okay, so this becomes slower. How do I do this also in my applications? Let me tell you one thing. Okay, y0 is going to be x of 2 times 0, right? Which is x of 0, which is 1 over here, right? So x of 0, y of 0 will be equal to x of 0. How about y of 1 or y of 1? Yes. Then it means t is going to be 1. I'm going to say x of 2 times 1, which is equal to x of 2. Okay, what was x of 2? 0, or on the original signal, it was 0, right? Now, at x equals 1, it is 0. How about x equals y equals 1 over 4? That means I'm trying to find out the value of my y function or y signal at 0.25 seconds. What is it? 2 times 1 over 4 is equal to x of 1 over 2. What was x of 1 over 2? Here it was. Now I'm going to find out 1 over 4. It is the same signal, right? So if you don't remember how it was like squeezing or expanding, we can also say the signal is squeezed. Okay, squeezed, sıkıştırılmış, and here the signal is expanded. Okay, if you think the same thing in the discrete time signals, here is my original signal. What should I do when I say xn equals 2xn? It will be a squeeze. It will be faster. But for example, do I have y of 1? For example, what is y of 1? X of 2, right? X of 2. I put 1 instead of n. What is x of 2? This one. Now, how about y of 2? It is x of 4. So it is this one. So when you think about this, actually, I'm just picking this signal as the first signal, 0 at 0 sample, sample as equal to 1, sample equal to 2, and so on. Okay, these will be gone when I say y of n is equal to x of 2n. Okay, it's a kind of subsampling. It's a kind of subsampling. Okay, I have values at all time instants, but when I say I'm making it faster, I'm losing these the old time instants. So if we were to do the same thing with y of n is equal to x of n over 2, what would be the result? Y of 1 is equal to x of 1 over 2. Do I have this, x of 1 over 2? No. So there is no y of 1. Okay, we immediately say y of 1 is equal to 0. How about y of 2? It's equal to x of 2 over 2, which is x of 1, and x of 1 is equal to this value, right? This value. Let's say it is 1 here, okay? So these are, let's say, 2, and these are 1. So what would I say? When n is even, I will get the value. For example, when n is 2, I will obtain this one. When n is 3, again 0. When n is 4, this one. So my x of 2n, x of n over 2 will be y0, 0, 1, 0, again 2, 0. So now I'm expanding my signal by introducing zeros in the odd time instance. Okay, so I want you to think about this operation here. These are like time scaling, either squeezing or expanding the signal, making it faster or slower. There's a difference between time, continuous time, and discrete time applications. Let me move on to the reflection. This is also critical arkadaşlar. What do I mean by reflection? Okay, ayna görüntüsü. Okay, mirror image of a signal. So you see x of t is this, and y of t is going to be x of minus t. Okay, so what do? I will take the mirror image of this part as this part. Okay, t1 minus t1 will go to plus t1, minus t1 over 2 will go to plus t1 over 2, and I will take this, the mirror image, let's say symmetric of the signal with respect to the y-axis. Okay, this is my y-axis. So this is how I take the reflection of a certain signal. Okay, what does it mean, reflection? It's like, for example, before the things that are happening before zero, it will happen after zero. Okay, it's just like reversing my signal. The later happening thing or early happening things will appear later. Okay, like writing my my merhaba in the opposite manner. Okay, it is something like that. Okay, this one will appear at the end. This one will appear later. Okay, this one is appearing at the end. It's something afterwards happening later. Okay, so this is how we should think about reflection. We talked about time shifting in the class. If you think about time shifting, okay, what would we say? Xt minus 2 is like shifting to the right. Shifting to the right. It also means delaying a signal. Okay, how do you do this? Let me explain. Like y of 2 is equal to x of 2 minus 2, which is equal to x of 0. Okay, my y of 2 value, okay, my y of 2 value, which is somewhere here, 2, now it is equal to x of 0, this one. Y of let's say y of 2.5 will be equal to x of 2.5 minus 2, which is x of 0.5, which is this value. Okay, so what will be my function like? Same signal, but now it will start from 1.5 and go up to 2.5. And my function value will not change at all. Okay, so I'm just shifting my signal to the right. If I do the reverse, x of t plus 2, then the signal will move to the left. Okay, same signal, but now this time my zero here will move to minus 2. Okay, if you think about this in terms of putting values over here, y of minus 2 will be equal to x of minus 2 plus 2, which is equal to x of 0. Okay, so my y of my y value at x t is equal to minus 2 second will be equal to the value at x when t is equal to 0. Okay, so I want you to think about all these together. And finally, when we are trying to combine these operations together, we will be talking about these kind of transformations also. For example, what do you see here? There is one time scaling. Okay, this is called time scaling. This is called like shifting, time shifting, okay? So now if we have both of them, what should I do? Okay, so I talked to you about these. If A is less than 0, it is like, it's called reflection. If A is between 1 and 0, then it is like stretching, okay, or expanding the signal. If A is greater than 1, then it is compression. That means squeezing the signal, making it faster. Okay, these are critical things. If we would like to do like y of t is equal to x of 2t plus 3, what are we doing here? We will want my signal, original x of t, to be shifted, to be reflected, to be compressed or expanded, whichever is wanted here. I will be doing over here. First, we should always think about doing the time shifting arkadaşlar. So what should I do first? Y of t is equal to x of t plus 3. Okay. What is x of t plus 3? So let me say v of t. This is a kind of intermediate step. Okay, this is an intermediate signal because my y of t is equal to 2t plus 3. My v of t is equal to x of t plus 3. What should I do next? Then y of t will be equal to v of 2t. V of 2t will be equal to x of 2t plus 3. What does v of 2t mean? When you see a t, put 2t instead. Okay, this is what we mean by v of 2t. So what happens here? This is 2t. That means it will be faster. My signal will be squeezed around this signal. That I will keep the same signal, but it will be squeezed. Okay. So what should I do then? This is my v of t. If I say, how will I squeeze it? Y of, for example, 1 will be equal to v of 2. Minus 1 is equal to v of minus 2. V of minus 2 is here. So now it's shifted to minus 1 here. Okay. So if I say y of minus 1.5, v of minus 1.5 times 2, which is minus 3, now this will shift towards here. Okay. So it will be like squeezing the signal. It's not going to be 2 seconds anymore. Now it's 2 seconds. Now it is like 1 second. Okay, it's going to be faster. Let me remind again. First, if we have something like that, we should first do the time shifting, then we should apply the time scaling. Okay, so let us do the similar thing for the discrete time signals. If I have x of n like that, 1 volt at 1 and 2, and minus 1 volts at minus 1 sample and minus 2 sample. Okay, so what should I do first? I should first shift my signal to the left. Okay, to the left. So because it is plus 3, this means shift to the left. Okay, shift to the left. Shift to the left means advancing. Öne almak. Okay, not delaying but advancing. Keep something earlier, make something earlier. Okay, first we do something like that. Then we should think about 2t. And now I'm going to work on this signal arkadaşlar. Now I'm going to work on this signal. What should I do here? Y of minus 1 will be equal to v of minus 1. Okay, v of minus 1 times 2. Minus 1 times 2, which is v of minus 2. What is v of minus 2? It is over here. So minus 1, this thing will go to this. Okay. How about y of minus 2? V of minus 2 times 2, which is equal to v of minus 4. Okay. What is v of minus 4? It is here, and it will go from here to this one. How about this signal, this value, and this value? They're going to be gone arkadaşlar. Because this is like making it faster, I'm going to lose the odd ones. Okay, they are going to be dismissed from the signal. Only I will take the odd sample, even samples. Okay, at x equals -2 and x equals -4. So this is how we do in terms of time scaling, reflecting, and I want you to do the similar thing at home right now. How about x -2 plus 3? How would I do this new signal? So I want you to think about this and then see you in the next video.